Alright, so here we define the expectation for a continuous random variable. Recall the way we defined the expectation of a discrete random variable x. So we defined that if x is a discrete random variable, then the expectation of x is the summation of x times the probability that x is equal to x, where the sum goes over all values of x. And if you recall from previous videos, you recall that the expectation means average, so this gives you the average value of x in the long run. So think of this probability as the relative frequency of, so this probability in the sum is the relative frequency of the value small x. So when you multiply x with that and then you sum over, you get the average value. And so how do we define the expectation for a continuous random variable? So if you recall, if x is a continuous random variable with the PDF small f of x, then f of x dx is approximately the probability that x is near x. So it makes sense, just like in the discrete case, to define the expectation of x to be the integral from negative infinity to infinity of x times f of x dx. Integration is just a continuous version of summation. So this also gives you the average value of x in the long run, and a lot of the times we use the Greek letter mu to denote the expectation of x. Sometimes if we need to emphasize the variable, then we can put that as a subscript on mu. So this is the definition of the expectation of a continuous random variable. Let's do an example. So let's say I have this PDF where f is 1 and when x is between 0 and 1 and 0 otherwise, and we want to find the expectation of these variables. Find the expectation of x. So how do we do that? Well, we just use the formula for the expectation. So the expectation is the integral from negative infinity to infinity of x times f of x dx, but because f of x is 0 unless x is between 0 and 1, this integral reduces to the integral from 0 to 1, in which case f of x is just 1, so we get the integral from 0 to 1 of x dx, and which if we calculate would be just half. So the expected value of x is simply half, and which should make sense to you, because if the way the PDF is, it's always 1 when x is between 0 and 1 and it's 0 otherwise. So it seems like x takes on any value between 0 and 1. X is equally likely to take on any value between 0 and 1, and so the average value of x should be half. Okay, so that's what the expectation is, and in the next video we will look at how to find the expectation of a function of x.